My name, as Valentin said, is Giacomo Inches. I'm a colleague of Valentin and Martel Innovate, and I'm representing the lab that in Martel Innovates deals with prototyping, IT prototyping for research and innovation. My presentation, well, this slide I thought I was presented before, but it's not. So basically, these are the different layers and verticals of the ARCADIAN-IoT project. And you can see the different use cases that we have in Arcadian, the different tools. And I just want to remark the fact that today I will focus on this tool called Self-Aware Data Privacy that is developed by Martel. And later on, you will see some presentation from our partner X-Lab on the ARCADIAN encryption. Why should we have the self-aware data privacy component? So the goal of this component is to protect data accessed by an API. So in informatic language, an API is an URL that you can call, and then this URL will give you some data in return. In this case, I just put some examples that allowed me also to thank our colleagues, Gabriele and Valerio, that helped me with the slides. So in the moment you call this API, you get some data. Maybe this data should be accessed only by a specific person, and maybe only, maybe you don't want that this data are released as they are. So maybe you want to anonymize or encrypt some of this data. And the self-aware data privacy allows this and allows the user to specify these rule and these policies. That's the bird eye view of how we structure the component. So there will be, so you can imagine the component, the self-aware data privacy component made by different blocks. The first block is a block that defines access policies, so that specifies if a user has access or not, so should have access or not to some data. Second block is the privacy definition. So it's the specification that if the user has access to the system, then which data can be accessed and how this data should be accessed by a particular user in a particular scenario. And this is more on the user side. Then from the administrator of the data side, so if you need to specify these policies, in particular the privacy policies, the recommender, the block of the recommender, gives you suggestions how certain kind of data should be protected, so that you can have an idea, if you don't know, how you can basically expose your information outside. Now, everything is mediated by an UI. In this presentation, and we only present you the UI for the recommender system, because it's more on the empowering the users towards the privacy policy specification and getting recommendation on how to specify these privacy policies. And another component, another important aspect is that the whole component is open and can be open to the external libraries. For example, in the case of policies enforcement, so basically the libraries, the informatic tool that allows to transform the data and protect them. So we can rely on external libraries, for example, the ARCADIAN encryption libraries by X-Lab. So we have one demonstration inside Arcadian that leverages the two technologies together, so self-aware data privacy and ARCADIAN encryption. But Nate will give more information about this in the next presentation. Now let's start with going block by block, so that you can see how this component is made. And then the first block is the access policies one. So why it's important to have a block that deal with access policies? Because if you give users the possibility to retrieve data via an API, this rule of access to this API, they shouldn't be attached to the API itself, but they may reside, they may stay in another repository with some specific vocabularies that specifies them, because then they can be basically audited for access. These policies can be transformed in other policies, maybe in different languages. And then if the policies are not tied to a single component, they may be shared among different components and distributed in a cloud native scenario. Now, when we say policy, it's different from the legal term in this case, because it's a very technological term in this case. It's very tied to the security domain in the IT. So for this policy, the minimum tools, the minimum elements that are needed to specify a policies are the actors. So who can access a certain API? So which action can the user perform on this API? So if you can read, but also or write or transform or modify. Which resources or which data that it's accessed by the API. So which identifier for the data and which kind of resource. So these are actually in a strict sense optional, but we put it here because we're leveraging on the fireware architecture, and therefore this is one of the mandatory type, the mandatory field when specifying data access. Now, as I said before, the coupling is important because then you can basically specify the policy once, but you may convert it into different specification depending on the APIs that allows to access this data. So, for example, in the fireware language, there are different possibilities to access the data, or you may even have your own API that may leverage these policies already defined. Now, just to give you an example, this is the basic way of writing a policy. So which access to give. So star means all the access to this entity. Sorry, access is the kind of user. So in this case, every user is allowed to access the entity with the permission of write via a certain agent. And then this is identification of the agent, but it's not relevant for the policy. But it's important that you can see that you can specify, if you don't want all the users to access the certain entity, the certain agent, you can basically specify only Giacomo can access. And then you can say, maybe I don't want that Giacomo can write any data, but they can only read this data. Now, once you have the policies in this format, you can convert in other format, and that's thanks to the decoupling. So you can basically convert, for example, in the web access control language. So it's exactly the same information as before. So the same agent, so the same entity that should be accessed, but with the same permissions. But in this case, it's another format. Now, in terms of architecture, yeah, that's the way we implemented it. So this is the vision from the user that wants to access a certain API. So the user makes a request, and together with the request of the user, it comes a token. So a token is a unique string that contains information about who this user is, which group he belongs to, if he belongs to a particular not just group, but also company. Then this request is intercepted, and then the OPA, which is the engine that it's evaluating the request, is basically asking the policy administration where we have the policy specified, and then verify if the user has the given access. So if the user exists, so it basically does the match between the information in the token and the information in the information system to see if the user is really who he claims to be, then it checks if he can access or not a particular API. Now, this is only for accessing an API. Now, the next step,
would be basically to define how the data that have been accessed, if granted, can be visualized by the user. So in this case, we have a similar system that allows to specify policies, but in this case, not policies for access, but policies for example, anonymization of encryption, so for data protection. Same advantages as before. You can have these policies written once and then applied in different scenarios, and they can be fine-tuned up to the attributes. So not just a single entity, for example, a single person, but you can basically specify different attributes like the name, surname. So like before, so the resource, in case of writing policies for the privacy, you have a unique identifier of the resource, the type of the resource. For example, a resource could be Giacomo, which is a human being, and Giacomo is identified by his name, surname, date of birth, and so on. And then we can specify, well, first I go with the technique. So which technique you want to protect this particular data. For example, you want the name to be anonymized when accessed, and the surname you want to encrypt for whatever reason. And then you can decide in the modality if you want to encrypt it only when the data is transferred among the systems, or if you also want to encrypt or anonymize or protect the data also at rest, which means when they are stored in a database or in a repository. Now, our tool focuses more on in transit, while I think the next presentation will focus more on at rest. So I'll give you examples here on in transit. So this is an example of in transit. So the policy says that this particular resource of type person that contains date of birth and email, when it's exchanged between a user and a backend and a backend and a user, should be anonymized. So in this case, these are the data as they are in the system, in the backend, so in the database or in the repository. So there is a specific date of birth, a specific email, and in the moment a user accesses it and the system, the privacy component, process it basically anonymized. So the date of birth is completely different. So only the decade is maintained here in this case, while the for the email we just put some stars to basically make it possible to see the real email address. Now, as before, this is the architecture, and it's still the architecture from the point of view of the users that wants to access a particular data. So as before, there is a user coming with a token. The policy enforcement point look if a particular data can be accessed, and then based on the policy that specifies how to treat the data, the component it's returning the action to be done. And here there are, as I said before, some libraries, internal or external, that can facilitate this data protection, so by anonymizing, encrypting, and so on. Now, I just want to compare the two architectures. As you see, they are very complementary. So there is a request of the user, there is a token coming in, there is an enforcement point, and then in one case, you first check the authentication and access, and then you can go and check once you can access the data, how the data should be returned to the user. Now, putting everything together, that's the joint picture. So, and it's basically first this action, the first error, and then the second action. First the access control and then the protection. Now, you see these fancy names, Anubis and Amon, because we named these two tools, Anubis in the case of access control and Amon in the case of policy specification for data protection. And then I'll let you look and search which kind of old Egyptian divinity are those and why we exactly choose them. Now, what is missing in this picture, but I don't have time to explain it, but you will see an example from the other perspective, from the system administration. Of course, these policies for access and these policies for data access
should be specified by someone. So what is missing here is basically a system administration user that is able to specify these two kind of policies for access and for data protection. Now, we do also have graphical interfaces for Anubis and for Amon, but you will see an example when now I'm presenting the recommender. As I said, Anubis and Amon, they allow users to basically make sure that the data accessed only by person that should access them and in the way that they should have visibility on this data. Now, from a system administration point of view, how do you know if a particular data needs to be encrypted or needs to be anonymized or it can be released as it is? In our component, we developed this proof of concept or recommender with some UI to make this process easier. So my next slides will be about that. Now, as I said, this is a bit of a summary. So the recommender, given a specific data type, data entity, so for example, a medical patient that has some attributes, as we said before, these attributes may need to be protected. And then each attribute may have a different technique. And then the recommender may help the users to do this. So this is a few screenshots of the interface. It's very basic because we're focusing on the core functionalities. So you can have a list of resources. So for example, medical of the TI per patient. And then for this kind of resource, for this medical, you can specify a name, a protection technique, and then the modality, as I said before, in transit or at rest. And as I said before, we are focusing more on in transit. Now, what does the recommender do? The recommender, once queried, so once activated, can suggest one or more techniques to be applied to a given attribute in a specific context. So given the type of the entity and its attributes. And now I have a screenshot of this. So if you think before on a specific medical patient, then you can have two attributes associated to this entity. You can have a name and surname, and then this technique you may have specified with Amon, okay, with the tool that I presented before. Now, in case of the name, you specify symmetric encryption. In the case of surname, you can specify pseudonymization, but the recommender system may give you a different suggestion. So you in this case it's matching. In the other case, in case of the surname, is not necessarily matching. So, but you can see what the system is suggesting you. Now, you may wonder, where do we get this data? Now, let's look at this picture that is the joint architecture with Anubis, Amon, and now the recommender. And as I said, this user here of the recommender is the administrator. Now, the recommender API leverages a configuration file. In the configuration file, we basically collected the knowledge about what happened in a particular domain, about these attributes associated to a specific entity. So, for example, we try to collect information about in the medical domain, and I'm mentioning this because it's one of the medical domain that we have in Arcadian. So, for example, if you have a patient, so how the data are protected. So, and we did some assumptions. So we basically guessed that in case of the name, we may want to anonymize, and in case of the of some personal vitals data, we may just approximate the data, so we don't give the full value, but we only give some approximate value. So in the configuration file, there is all this knowledge, and it can be extended. So we could not do within the scope of the project, but in the configuration, you can also put some AI algorithms that leverage more knowledge, or some LLMs if you really want. And what is important is that the recommender is basically helping the user, and then basically joined the policies that I've written before with the one that are best practice. Now, I have a video in the next slide. I hope you can see it, that shows a live example of this recommendation. So everything starts by adding a new resource. So in this case, the resource is called Gabriele, and the type, I think, is a patient. So we are supposing Gabriele needs to be treated in some hospital. Then Gabriele, we specify, may have a name, and we don't want that this name is revealed, so we anonymized it. And then we say in transit, as I said before, that's the focus. Now, after a second, we receive a message, and then this is saved in the interface. Now, if you click on the locker, you can see the current anonymization technique and the recommended ones. And then you can edit it, and you can make it matching, for example, the recommended one. In this case, you save it, and then you see it, boom. This interface gives you the match by the full color of the labels. Now, if you want to add a new attributes, for example, age, you say, okay, I also anonymize the age, and the recommender doesn't contain any value, so the system is telling you accordingly. So this is, as I said, a proof of concept, a first step towards empowering the users toward the protection of their data, because then it's a user, the data owner that can decide how their data are accessed and who can access and in which way. With this, I'm done. I only have a very few slides. So since we are still working on Amon and on the recommender, this is still work in progress, so we have not yet released as open source but you can find Anubis already released. So the access control system, it's open source. You can go on GitHub, that's a link. You also can find in the same link, if you browse, an interface for Anubis that is very similar to the interface that I've shown to you. And we are continuously working on the two components among the recommender in Arcadian. So the few dependencies and libraries that we have used, and I said, we're leveraging the firewall standard. And with this, thank you, and I'm ready to take any questions you might have.